paper 2 style question. And for this one, we have this manufacturer that's making trash cans in the shape of a cylinder with a hemisphere, so half of a sphere or circle, ball on the top of it. And we need to write down the height of the cylinder. So if we know that the radius is 20, that's given to us just here, then that means that the radius of the top of the cylinder must also be 20. And since it's a sphere or ball shape, that means that this is also the radius and therefore also 20. And so the height of the cylinder part is 70 minus this 20 here, and therefore is 50. So the height of the cylinder is 50 centimeters. Don't forget your units there. It's not labelled on the diagram, but it does clearly tell us in the question that it is in centimeters. The next part says to find the total volume of the trash can. So using the formula for the volume of a cylinder, we know that that is pi times r squared, which is 20 squared, times by the height, which is 50. Okay, so the volume of a cylinder is a bit like a prism, and therefore it's just the area of a circle, pi r squared, times by the height, which is 50. And then we need to add to that the hemisphere, which is 4/3 of pi r cubed, so 20 cubed. But I don't need the whole the whole sphere. I just want the hemisphere, so I need to divide all of that by 2. You can either write it like this, or we can write it as, instead of being over 3, we could change that to over 6. Either of those methods is fine. Both times you're just dividing by 2. And that gives me the volume of the trash can, which is 79587. So you can type this into your GDC, centimeters cubed. So 79,587 centimeters cubed. And then it tells us that the designer is thinking of making a new trash can with slightly different dimensions. Okay, so again, they've drawn it for us. This time it has height h and it has radius r. But other than that, we can see it's exactly the same. It's just that we have some algebra in there, but the process to work it out is the same. The reason they've asked you A and B is so that you can get used to using the process, and we can then copy that same process in this next part of the question. So on this one, there's a design constraint. So we know that h, which is the height of the cylinder, plus 2 lots of the radius can only equal 110 centimeters. And we need to find the maximum volume for the trash can. So the first question simply says to find the height of the cylinder, which is h, in terms of the new trash can. So what I did last time was I took the full height of the bin and I subtracted the radius, and then that gave me the height of the cylinder. And I'm going to do exactly the same here. I'm going to take the full height of the bin, which is h, and I'm going to subtract the radius, which is this part here, and that gives me the new height of the cylinder, which is this part here, which they say is called h. So h is equal to capital H minus r. But in the question, they say that it should be in terms of r. So that means that I need to get rid of this h. I don't want it in there. I want it all in terms of r. But they gave me this earlier, which means that I can use this to try to replace the h and put it in terms of r. So if I take this part here, then I could rearrange that, and I know that capital H is equal to 110 minus 2r. So all I've done there is subtract 2r from both sides. And I could now replace this h with this here, which we know is equal to h. So I'm just going to replace them in. So h is equal to 110 minus 2r, and then minus r. So all I've done is replace this part here with h. And I can tidy that up and collect the like terms, so it's just 110 minus 3r. And that's then the answer for the height of the cylinder in terms of the R value for that new trash can. And then part D says show that the volume of the full trash can is given by this here. So again, let's go back to what we did last time. We need to find the volume. We had to find the volume of the cylinder and then the volume of the hemisphere. So let's repeat that same process again. So I have the volume of the cylinder first, so pi times, and this is going to be r squared, times the height. Well, I've just worked out the height, and the height is 110 minus 3r. So 110 minus 3r. And I'm going to just put that in brackets there. So that's the volume of the cylinder, and then I also have the volume of the hemisphere, which, like last time, is 4/6 of pi r cubed. So pi r cubed. And then together, this gives me the volume of the full trash can. So I'm just going to add those together. Let's do it down here. So we have pi times r squared times by 110 minus 3r added to 4/6 of pi r cubed. So the first thing I'm going to do is multiply out my bracket. Okay, now we know that we don't really need this times sign or this times sign here, so it's just pi r squared times by everything in the bracket. So thinking back to what I've done lower down the school, I can just multiply that through. So I have 110 pi r squared minus, and then I have 3 pi r cubed. Okay, I've got the r squared times the r, and then I have to add on to that 4/6 of pi r cubed. And you can see there I've got 2 r cubes. So I have an r cubed term and an r cubed term, so I can collect those together, collecting my like terms. So I have 110 pi r squared, and then I'm just going to type into my calculator minus 3, which is how many pi r cubes I have, plus 4/6 to find out how many pi r cubes I have. And that gives me negative 7 over 3, so that means I have negative 7 over 3 pi r cubes. And this is what it asked me to show, and therefore I've shown it through my working here. So that's this part here. A lot of people find that question, any show that question, is probably one of the hardest parts of the SLAI course, and therefore it is totally fine to leave that question out until the very end of the paper and to come back to it if you have time. It's only 3 marks, but you can still answer the rest of the question. So if you're not sure about this, that is fine. We leave it out. We can still answer everything else, and then at the end of the paper, you come back and have a go. That would be my advice. So for E, we can still do this part. We're using the graphic display calculator, our GDC, to find the maximum value of V. So because it's always a show that means that you can continue the question. So I'm now going to go to my calculator and I'm going to plot this equation. So I have 110 times pi. So 110 times pi times, and it's r squared. So I'm going to write that as x squared since I'm typing it into my calculator. And I'm going to subtract from that, and it's a fraction, and it's 7 over 3, again pi, and then it's r cubed, so this time I'm going to write that as x to the power of 3. So I'm going to go to my graph. Now clearly the way that I've got my windows set up is not very helpful here, so I'm going to change this. I'm just going to change it to 50 to now, and my y-axis. Now if I go back to the first part of the question, you can see here, just on the top of the GDC, just here, that we were talking about 79,000 as the volume. So clearly my y values need to be significantly higher than what I've got here. So I'm actually going to type them in as, 100,000. so we can start to see what's happening. Now, there's obviously some part of the graph here. If I think about the equation, it's a cubic graph, and therefore, if it's cubic, we expect it to have that kind of N shape. So I'm going to go back to my window. I'm going to extend this a little bit further, and I'm going to extend this a little bit further as well. And now I can see a lot better about what's happening. So we need to find the maximum value of V, the volume. So the maximum happens just here at the highest part of the graph. So I'm going to go second function, trace, and I'm going to find the maximum value. So I select somewhere to the left, somewhere to the right, I press enter again, and this is the maximum value. So it happens when R is equal to 31.4 to 3 significant figures, and the volume at that point is 114,000 to 3 significant figures. 114,000. And the next part of the question says that, if I go back to the question so you can read it, it says that the designer claims that the new trash can has a capacity of 40% greater than the original trash can. And we need to say whether or not it's correct. So we need to compare the two measurements. Now, instead of using the rounded version, I'm going to use the more exact version. So the volume of this new version, instead of being 114, is actually 113,781.22. So I want to make sure I'm using the most accurate version that I can. Oops. So for this one, we're going to use the more exact version. So I take the new amount, 113,781.22, and I'm going to divide that. Let's just get rid of this part of the screen. I'm going to divide that by the old amount. So this was my answer that I did previously to part B, which is 79587. And that gives me 1.4296. And this means that it is 42.9 or 43 if I round it, % greater. And therefore, yes, they are correct with their claim. It is a 43% volume, better than the original one.